the panel then. Maybe you could tell us your name and what you do on the Go team.
Sure, thanks. Hi, everybody. My name is McIntosh. The Than is short for Nathaniel. It's a little weird, but that's what they call me. I work on the compiler and runtime team. So if the Go project were a cruise ship, I would be the person in the engine room working on the engine, making sure that it runs reliably and making good speed, that sort of thing. I work on the Go compiler, linker. I think that's about it.
Yeah, well, that's pretty good.
Hey everyone, I am Cameron Balahan. I am the product lead for the Go project. So I'm a product manager. And I guess in that sort of ship analogy, I would be the one looking at the map, maybe drawing on it somewhere, and hoping that I don't run us into an iceberg.
Hi, I'm Michael Knyszek. You may have seen me earlier. And I also work on the compiler and runtime team. I actually share an office with Than. And I guess so we're both engineers in the sort of train sense.
And where are you on the ship?
Our ship is in the Boston area, so Cambridge, Massachusetts. That's
nice.
Where we're.
Very cool. Okay. Right. Well, so let's get going then. We got some questions earlier. Somebody asks whether there's an easy way to use Go or with CGO with the msvc compiler, and they're sort of interested in integrating in other places. Is there anything like that sound?
Yeah. Okay. I'll take that one. Super technical question right off the bat. For those of you who are not aware, Go integrates well with C using CGO. So if you have a Go application, you can call C runtime libraries, do things, call out to packages that are compiled and built into a C library or shared library integrated in your application. So the person here is asking about whether they can use CGO with the Microsoft Visual Studio C compiler as opposed to the MinGW compiler. And the answer right now is no, you can't do that. We haven't been able to bring that feature out. And I think that this would be a great place where somebody from the external communities, like external contributor, we could use some help on something like that, because it's a very kind of boutique request.
Yeah, so what's involved in making that work? Are you just sort of, what's the kind of work you have to do to make something like that happen?
Many other C compilers will produce object formats like ELF or dwarf, that sort of thing. We can go and read those standards and understand what has to be done to kind of digest those object files. In the Microsoft world, it's a little bit harder to get sort of reliable information about the internals of how all that stuff works. So we would need somebody who's kind of a Windows expert already.
Yeah, I see, that makes sense. Cameron, you mentioned that you used to do C and C++ before with like low latency stuff.
Yeah, that's right.
But you prefer Go, is that right?
Yeah, I do now. So for the longest time, I was a low latency systems developer. So all C, C++, close to the metal, and I think that stuff's great too, to be clear. But when I joined Google and I found my way to the Go team, I sort of really fell in love with this language. I thought it was, it made so many things easier. Yes, it wasn't going to be used for a low latency trading system, but there were other things about it that made it so easy to get started that it was like a breeze to learn. And that was pretty refreshing. And then since then, it's been awesome because I love the community. I love the sort of the members of the team, the language itself and its philosophy. So that's why I think it's become much bigger of an affection than I had for C and C++.
And you're a product manager, and so this is an interesting thing for me that you have a product manager for a programming language, and you talk about like it's easy to pick up. Like, how much attention is paid to like the usability, the product side of a language, and what does that really mean?
Yeah, quite a bit. So it means a few things. When we think about it, we think first the community, like the bigger picture. You all here today. How do we continue to make the language better and still adhere to the principles that we think made it the sort of success that it is today. On the other hand, we also have to think about how to have this project persist at Google. So, how does Google get value from the language? And the truth is, it's through things like its engineering excellence. Go demonstrates that, or its thought leadership, its ability to sort of say, here is our view on something. I mean, Google also then uses it internally, of course, and there's lots of benefits to that as well. But just externally, being sure that all of that is aligned right, that the right stakeholders are happy, and that the sort of direction that we're taking the language in makes sense for our objectives, which really are to grow the language, to ensure that it stays true to its principles and continues to sort of delight our users.
Yeah, well, do you think Go delights you? Do you feel delighted by Go? Yeah. But seriously, that is not true for all languages. Sometimes people have to use languages and they don't have a happy day, Michael, when we talk, your talk earlier, and we were chatting about, you've spent a lot of time with the compiler actually doing optimizations, doing things to make programs run better, run faster, use less memory, whatever it is. How much of that is, how do you decide and prioritize that kind of work? Because is it that you look for just what most people are doing and that's going to guide it? Or is it maybe comes internal things from inside Google? How does it work?
So that's a really good question. Generally speaking, lately, so typically we focus on the 80% case. We focus on making sure that most Go developers are happy with performance and that we're meeting basic needs and keeping satisfaction high on that degree. It's always a moving target, though. Every day, the performance of everything is getting better, and so we have to keep up at least a little bit. I think we've been doing a pretty good job of that. Outside of that, we tend to sort of new features are targeted at the 80% case, and then as time moves on, we really focus on the long tail cases. So we tend to design features to have this sort of to be a little bit open-ended, that yes, it's designed for this 80% purpose, but can we also cater to other things in the future as future work? And I think a really good example of that is how the Go garbage collector had, a long time ago, in 1.5, I think, had a massive rewrite to reduce latency. And yeah, for most people, it was a dramatic improvement. But over the years, there are still lots of little bits, long tail of problems where people still see significant latency hiccups just because of precisely what their application is doing. And so over the years, we've been fixing that up little by little, and the whole system becomes more robust in the process. And slowly that 80% turns into something more like 90 or 95%.
Yeah. Great. Well, I love the fact that as a user of Go, I can sort of not worry about what's going on under the hood. I can sort of I focus on the language, and that's not changing that much, apart from some recent examples there. And so, yeah, thanks for doing all that hard work, everyone, by the way. Okay, so who has a question that they want to ask for the Go team? Right, literally, I'm going to throw this down. So I'll be honest with you. I am not good at sports. This is a sport to me. This is what I think sport is. How about I just pass it to you and then you pass it behind? Is that all right? You can throw it. I just don't want to get in trouble. I don't mind if you do. So please, yeah. Do you want to ask a question? Oh, that box you've got is a microphone.
Oh, okay.
Yeah.
Will there be a time that you will think that Go 1 is complete and you will stop developing it, and sometime Go 2.0 will be released?
Yeah, I can take that. So I think throughout the history of Go, there's always been this idea that there will be a Go 2. And there hasn't been, because we continue to maintain the compatibility promise. And so we don't we don't want to break our older users. Yeah. So, what happened in Go 1.18, the change, the generics really in particular, that change was the biggest change that's ever happened to the language, and it is the biggest change that will likely ever happen to the language. So I think, I can't look that far into the future, but I don't see it happening anytime that I can see.
You know you're in a geeky community when people are cheering for a backwards compatibility promise. Do you know what I mean? Yeah, rock on! We're cool. Cool, thank you. And there's one directly behind you, if you could just throw it. Don't look, just throw it.
Hello.
Hello.
So I've been working on integrating Go with our hardware. We build card readers, and we have sort of Linux on a constrained resource environment. And we traditionally write all the software for it in C, but I wanted to write applications for it in Go. So we've been interacting with GLES, linking GLES and GLES v2, so OpenGL for embedded systems, and doing the EVDev stuff in Linux for the multi-touch support with the screen. And my question is, we've found that the CGO overhead is quite large, especially when we're doing rendering on an embedded system. And I was wondering if there's any chance or anything in the roadmap to improve performance of CGO programs, or reduce overhead.
I can say a little bit about that. I mean, we don't have any concrete big plans like right now to dramatically improve CGO performance. It's sort of the thing that's in the back of our minds, like we know. And there's a lot of things that make this difficult. We do have some ideas brewing. I don't know if they're even like old enough or like sort of mature enough to say without like causing mass confusion or anything. But I think that like for your specific use case is quite interesting because are you aware of the Go mobile package, for instance?
Slightly, yes.
So they also have to deal with this issue that there's CGO overhead and they're interacting specifically with like OpenGL.
Yep.
And what they did there was sort of that on the Go side, you kind of maintain a queue of all the things that you want C to run. And so you try to cross that boundary as few times as possible. And it was good enough for the experiment that Go Mobile was, and like people still write mobile applications and they work. I'm off the top of my head, like a few of the open source game frameworks that people have made also do the same thing, and it's pretty effective. But it really depends on your constraints, and if it's specific, file a bug, file an issue. The more data we can have on this, the better we can help prioritize these sorts of things. Yeah, so that's on the GitHub project specifically.
Yeah, I was going to ask, where do people go to file bugs then? Where do you want them to go?
Yeah, so the Golang organization on GitHub has the Go repository, just called Go, and just file an issue there, follow the templates, and yeah, someone will take a look at it.
Yeah, great. Okay.
There are also, there's a proposal template there too. If you want to sort of really engage and have an idea like that, you could get it at that same repository.
Yeah, and to be clear, the proposal is like if you have something specific in mind that would help, that's a really great way to get a discussion going.
Yeah, I think what we've been trying is just, as you said, batch up the things and then cross that boundary as few times as possible. But it'd be really nice to simplify our code if we could, make it more doable. Yeah.
It's totally understandable. There's just some things that are outside of our control. The things that you can do with C, we can assume very little. A lot of our ideas focus around like, things we can do to pinky promise, and at least in like some corner cases, help get things across the boundary that are a little bit safer and more constrained.
Yeah, good question. Any other questions? Oh, we have one down at the front here. Oh, here we go. Look at that. Wow.
Hello, my question is about field alignment. It's an issue or a comment that you can get when you just order the items in your structures in the wrong way. And why is it not already taken care of by the compiler and not the developer.
Just to make sure I understand, you're talking about structure fields, and why doesn't the compiler automatically reorder them?
Yes.
Okay.
To minimize space and optimize usage.
Yeah, there's a specific order that you put them in that's optimized, right? And you'll get smaller structs because of that. So why doesn't the compiler do that for you automatically?
Yeah, that's an interesting question. So I think part of it is sort of a principle of least astonishment. A lot of people would be surprised if things like that were happening behind their back. There's other things like passing structures from one function to another by value. If you don't really know who's calling you, you don't know which reordered version of the structure is coming in, that sort of thing. So it's an interesting idea. Michael, do you have anything to add there?
Yeah, I have a little bit to say on that. I think it's technically allowed by the Go spec. So there's technically nothing stopping us. I think what in practice is actually stopping us is that we don't have, there are a number of cases where you do really, really want to specify the order of the fields, and we don't have a way to do that. There have been numerous proposals over the years, and I don't think we've quite settled on anything. Everything always had some kind of issue. We'll get there. I don't think that's something that's completely off the table. I mean, the things that Dan mentioned are definitely also the things that get in the way. But it's something we've been thinking about because there are sort of like other problems that having that would help solve. And so kind of the moment we have that, we can also start thinking about this.
Does it move them around at all at the moment?
No.
No, yeah, it's because like sometimes when like some serialization that you do, if you're going to be transmitting over like gRPC or other kind of protocols, like sometimes like what you end up with matters, and you have to be kind of aware of it. So yeah, it's the kind of thing where I'd feel like that was too magic if it did that. But I'm sure there must be a tool that you can run explicitly to do it at dev time, right?
Yeah, some linters will be unhappy if you don't align them properly.
Right.
The linker does a fair amount of reordering of variables. So you might write your variables in one particular order, and they'll get completely rejiggered and reshuffled. But you certainly don't touch structure fields.
Yeah, that's a good question there. Thank you very much. We've got another one over to your right, over there. Good throw.
So we have a fair number of pure Go applications that we're running, and then we have a smaller number of C-Go applications, for which we need to use some imaging libraries. And the one thing that I really love about Go is that you can basically compile from any platform to any other platform. But as soon as we go into the C-Go space, then this all breaks down, because for every supported platform, we need the correct compiler. So we need on Mac Windows or on Mac Intel, we need then the Linux ARM compiler and the Linux Intel compiler and so forth. So it just makes compiling these specific artifacts, these specific versions, way more complex, and it kind of breaks and ruins the whole experience, because all of a sudden we're exposed to the whole mess of CI systems and maintaining different compiler versions on different developer platforms. So would you ever consider building basically a C compiler into the system so that you can not only compile Go code, but also C code cross-platform?
Oh boy. Well, first of all, I hear you, and because we go through that same pain in the Go team as well. There are parts of the Go standard commands and standard libraries that are use C-Go, and we have the whole experience that you have of trying to line up cross compilers, and it's very challenging. As far as signing up to write a C compiler, it's not really on our plans.
You're good at compilers, though.
I mean, the C compiler community is moving in the direction of making cross-compiling more easy, right? If you compare building the pain that you have to go through for a GCC cross-compiler is a lot more than what you have to go through for Clang cross-compilation. But I agree, it's still a huge hassle. I'm not really sure what the Go team can do to help with that pain.
I have a suggestion, not necessarily an endorsement, but something I've seen people do. Not an endorsement, not because it's good or bad. I just don't know enough about it. But we've seen some people like file issues against us, people that are using, are you aware of the Zig programming language? So they actually did do that. They implemented a portable C compiler, and they set their CC variable to Zig CC, and it's also a cross-compiler, and it works more like Go. So that might be worth looking into. I don't know how well it's going to work out, but some people, swear by it. So,
is this the same project that's because I've seen that there's a native version of SQLite for Go, and I thought, how's that possible? But they're basically they're transpiling C code to Go code and then run it through the Go compiler.
I think that's distinct from Zig.
Yeah, Zig is its own programming language.
Okay.
It's relatively new, but as part of their interops story, they actually re-implemented a C compiler, a portable C compiler. So
Okay.
What do you think of that idea, though, of transpiling C into Go and then?
I mean, it exists. SQLite works apparently. So I mean, that was kind of as a shock, right? So that this is actually doable.
Yeah, it is a shock.
Yeah.
Okay, thank you. Any other questions? Oh yeah, so behind you, look in the corner.
Okay.
Throw. Whoa! So close.
So I'm going to ask a question based on one of your answers. You said that Go 118 generics was one of the biggest changes that ever happened to Go and that will ever happen. How do you keep up with innovation? How do you keep up with Go still being used in the future? What do you plan for the future if you're just going to do some small maintenance here and there or adding smaller features? Do you have anything envisioned to add more bigger stuff to Go to make it coming on the future for the new generation of languages that are showing up?
Yeah, that's a good question. So I didn't mean to imply that everything that we do going forward won't be meaningful or that it'll just be small. Just that generics is a really big thing. It's something that was talked about since the inception of Go and took a very long time to get right. And it's still a work in progress, actually. It's something that we're trying to polish in the next version and so forth. So there's still a lot of exciting stuff coming. Now to answer the meatier question, how do we think about that? How do we think about where to sort of go next? Well, one of the things we do is we think about what do our use if our objective is to grow the language, to make it more increase the number of Go developers out there, make it so that it's easier to use, people start up faster, whatever, those sorts of things. Well, one of the things I think about is what segment are we not in? So, it's in these sorts of projects, you have early adopters early on, you have hobbyists, you have things like that, but there's only so many of those. And then you think, well, where can we go next? And something we've done in recent years is we've thought about the enterprise. How do we get ourselves in the enterprise? And this is important to a language's survival. If you look at other languages, those that didn't make it to the enterprise sort of stagnated and died away. Like Ruby's an example that comes to mind. It's not dead, but it hasn't grown in the last 10 years. And then you'll think about Python, which has grown quite a bit by finding a place in the enterprise. Go's trying to do that too, and it's been very successful in recent years. And so one of the things that we think about for enterprise use cases that we think sort of on the horizon of all of this is security, especially in your dependencies. So, the fact that there's an intricate web of dependencies, your dependencies and the ones your dependencies rely on, like your transitive dependencies, and knowing that a bad actor can inject themselves at any stage in there and affect wide swaths of the Go ecosystem. That's something that enterprises, we think, care about. And so, we have a lot of stuff in the works right now for a curated vulnerabilities database and an integrated end-to-end experience with that so that we can try to minimize the number of vulnerabilities that creep through. Fuzzing was introduced in Go 118. That helps you secure your own code. So that's a security piece that goes to thinking about new innovations that's sort of pinned to the enterprise. And then we try to think about what other ways are we able to hit our objectives, get users comfortable so that more and more users are coming to Go. Like maybe getting started easier. Again, it's not that generics is the end of Go or like feature development of Go. It's just that it was a really big deal. I don't think anything else can be as big as that. That was particularly big. But there's a lot of good stuff coming in, and we've had a lot of success with all of this sort of like looking at another avenue to pursue, the enterprise in particular. We've seen a lot of success with that. So I think there's a lot of exciting days ahead as we try to make that better.
And I just want to say one thing. I found that question really interesting because when I think about my day-to-day work and like the stuff that I feel like could use a massive improvement and would affect people, there's like no end, no end to that. And a lot of that stuff isn't that small. So just thinking about it from like, not even like just on the level of like Go, the open source project, I think there's a lot that can still be done beyond just maintenance. Certainly, yeah, as Cameron said, certainly not the end of Go.
Yeah, it's interesting that you talk about the security stuff and bad actors and stuff. I had a nightmare once that I ruined Testify by making flipping the logic in assert true, so it was false, and just ruined it. I genuinely had that as a nightmare, so I'm cool. Okay, thank you for that question. Yeah, we have one down here. If you could throw it over. Yes, there we go. That was nearly terrible. You got 4 points. You hit 4 people. Congratulations. And the thing broke, which is actually a bonus point.
I wanted to ask about the governance model of development team.
No, it may be broken.
So is your question, how does one start contributing to the Go project, and is it limited to any particular sort of type of person, or can anyone do it? Is that what you mean?
Yeah, like generally what is the governance model for joining the maintenance?
Governance model.
Yeah, well, I could speak to some of that. I don't know, do you guys have better good answers to that?
We don't have a super formal process for folks joining Go. I mean, obviously we encourage people to contribute as much as they possibly can, and we have a big group of external contributors. I'm sensing that you're asking more about sort of governance in the sense of how do you become part of the executive committee for Go or controlling the direction of Go or something like that. Okay. Yeah, that might be a little above my pay grade, but
I actually don't know the answer to that either. But my understanding is that it's one of a continuous process of building credibility in the project. I can say, like, not to that question, but to the rest of it, it is open. We do have a pretty strong code of conduct, and we have a process for everything. So those things are important guardrails. But otherwise, I think it's wide open, and it's up to anyone who wants to sort of collaborate or submit issues or submit proposals or anything of that sort.
Yeah, I have friends who, in the comments, they didn't even create the issue, but in the comments, they contribute and they end up basically helping design the solution in that way. So it really is like, if you care and if you care about something and you want to get involved, get involved. I mean, and honestly, junior people also fall into this trap of thinking, these people know loads more than me, what could I offer? But your perspective, your unique perspective, is very valuable, especially like a fresh perspective. Turns out to be very valuable. So I'd say get involved. You'd be surprised. Okay, who else wants to be hit in the head? Okay, yeah, we've got a long. Oh, we don't have it. Oh, okay. I suppose I could run around like a lunatic. I ran that bit, and I'm not running. I'll walk. Okay. Who says a question?
Hello, thank you. I have a question about two pieces of the libraries which have not had much changes in the recent years, and I'm talking about the plugin system, the native plugin system, and Xtext. Plugins haven't been changed in at least 3 years when it comes to code, and they're very hard to actually use due to distribution issues, the need for the same compiler, same flags, and so on. Should we actually keep on trying to use them or move to, say, HashiCorp plugins, for example? And the other question is about the same about Xtext, which has a lot of ambitious goals, and it always had, but it hasn't made a lot of moves since mostly Marcel left, basically. Where is the language going about these packages?
Yeah, you're absolutely right. Xtext was maintained for many years by Marcel. He left the Go team, and since then we really haven't had anybody step in to take ownership of that particular part. That's a sort of key piece of Go. I don't know what to tell you. The Go team is not big enough. The Go core team is not big enough that we can assign, a core team member to every particular piece of the Go standard library and ecosystem. We just don't have enough bodies. We're really relying on external contributors for things like that. So, Michael, Cameron, do you have anything to add on that score?
I mean, lately we've been trying to sort of, we're making a push to try to give more of these packages shared responsibility, so that there is someone you can reach out to, or at least like a group of people that, even if no one particular, like the person who wrote that package left, like they can at least help pick it up and figure it out. We're still moving toward that. We're doing a bunch of kind of slowly going over the package list and fixing that out, but it's going to take some time.
I hear you. Xtext that's a particularly painful example of that situation.
Thank you. And we have another question here.
Here, it's not a particularly question. It's I want it's an opportunity to ask actual Go people about error handling. So I read everything about error handling, why there is a error handling in specific type in Golang. We write one line of a code, call a function, and write 3 lines of error handling. And sometimes we look like the code is whole error handling and don't see actual logic in it. And sometimes it's frustrating, not all the time. Sometimes it's frustrating. Logically, it is true. Why to handle the errors? Every error should matter. But how about you people? You are also writing Go code every day. Don't you frustrate any time? Okay, sometimes you feel error in your file only. Like if error is not nil, bubble the error. If error is not nil, bubble the error.
I don't mind it myself, but but I have that C background. But
oh no, you want to go?
Well, I just wanted to briefly say that we really do write code like that. Our code looks just like your code with lots of extra additional lines to handle the errors. So, Michael.
Yeah, I was just gonna say I don't know, maybe Than and I are not the best people to ask about this, because as we've been talking to people, Than and I don't, Than uses Emacs, I use Vim, I don't even use autocomplete, and I don't mind the error handling. I'm typing it out every time, but it's just code. Honestly, I spend way more time thinking about what I'm going to write than I do actually writing it, and so at the end of the day, it's kind of a pain. But the muscle memory is there, and as a result, I do feel like I find myself thinking more about the errors. I'm not saying in how they're presented and everything, and I'm not saying that this shouldn't be better. People on the Go team are constantly thinking of new ways to try to make this better. A lot of them don't make the cut, so you don't necessarily hear about them. But this is something that's still like there. It definitely feels like there's room for improvement, but it doesn't feel like a extremely urgent critical issue.
I might add that there, in the past, I don't know, 10 years or so, there have been many proposals on, hey, let's do this in order to improve the error handling. And to be honest, I don't think we really ever came to consensus on a one good way to move forward to make error handling a little bit more concise or to sort of do the things that people wanted to do. So the pot is still bubbling on that.
Yeah, but again, if you've got any ideas of your own, write a blog post, talk about them. Okay, another question down here, and we have our scary box back. It's working.
Test. Yeah. Yeah, so a few years ago, I was looking into using Intrinsics, and why is really not the point. But what I found is that through some blogs and people trying to figure this out, you can do this, but the only way that I could make this work was escaping to the Go assembly and using it. So there was some support for using this, but there's no actual standard library level support for using Intrinsics at all. Any plans, any ideas about this?
Just to repeat that, the Intrinsics, I assume you mean like SIMD
yes.
Intrinsics, that are currently only available in assembly, and there's no standard library support.
What are they for, just for anyone not familiar?
Basically, it's how to explain this. Basically, it's a kind of parallel processing, but like you say, instead of operating on a single element of a slice at a time, you load 4 elements at the same time into like a special hardware, like wider area, and then you do a bunch of operations on all of those things in parallel simultaneously. So SIMD actually stands for single instruction, multiple data. That's the, yeah.
Just to confirm, that was what you were talking about when you said intrinsics, correct?
It was, yes.
Okay.
I guess the other thing I have to say about that is that's interesting because that is a topic that has come up recently. This is something that I personally have thought about a lot. It's the reason we don't have an answer yet is because the field is quite wide on this, and it's only getting wider. If you've heard of like what the new stuff is on ARM, and the new extensions are on ARM, and like the RISC-V extensions, they look not anything like, or they look similar, but not really that much like what's happening on Intel chips. And this very much complicates writing something that's easy to use and portable. You know, of course, a non-portable solution is always possible, but that's a little bit against the Go sort of philosophy, right? It would be nice to just be able to like express like, this is a vector, do these operations on it, or even just like, you know, load this much at a time and do these operations on this like group of values at the same time. But again, it's really hard, and it's really hard not only to express that in a general way, but then also to figure out how to make that expression map down efficiently. And like other languages do it, there are pros and cons with their approaches, and I guess internally we just haven't really settled on something, but I think this is in dire need of a proposal to start up discussion.
It's something that we're talking about inside the team.
And something similar to what Michael just said. When I first joined the Go team, Russ or Steve Francia told me the default answer in Go is no. And then the reason for that is that yes is permanent. It means nothing else. This was what we chose. And no is temporary. It means no, but maybe later we'll do something about it. So until, and that's one of the sort of principles of Go is let's not confuse the language. Let's not make it more complicated than it should be. So, you know, with something that's wide open, that's still got a lot of possibilities, you know, I think it's probably the answer to a lot of the questions that folks have asked. The answer is no, but not permanently. We're trying to figure it out.
Yeah, and we all kind of benefit from that and being really careful. Like, generics took a long time, but, you know, we get, the fact is, like, we want this to be stable as a language. We want the backwards compatibility promises. In other languages, they'll try things, they'll try more experiments, and get the language out and then deprecate features and things like this. And it's a nightmare because you're trying to maintain older code bases. You have to often go back and rewrite chunks if you want to build it using modern tools. You know, it's a pain. So it feels bad, but it's a great thing. And I remember Steve Francia, I asked him if he wanted to go for a drink with me, and he just said no. So it's just like, that's his default answer for lots of things. I wasn't bothered, none taken. Yes, okay, cool. Right, we have another question at the back. Where's the box at the moment? Okay, so back there, and then we'll come over here.
Thanks. So in C++, there are many container types like deck, lists, sets, etc. In Go, I have to either reinvent everything every time or use some kind of libraries. So question is there a plan to have built-in such containers?
So you're talking about STL classes like vector and set?
Yeah, so like lists, decks, sets, binary trees. So in Golang there's like map and slice.
Right.
And that's
You know, maps and slices and that's it.
Yeah. So maybe like instead of reinventing set every time, maybe there's plan to have built-in.
Well, I think the one thing to point out is that we do now actually have generics. So that's going to help a lot when it comes to rolling out those types of container classes.
I saw one recently on Twitter, actually. Someone has made the full set. And I think this is what I think is kind of inevitable, that we're going to have different flavors of that. So I think the time when I'll trust it is when it's in the standard library.
I will say there is in the, this is going to be really hard to say. It's a lot easier to read. x/exp package. Inside there are a bunch of sub-packages. With experiments, I think it already contains like a slices experiment. I don't know. Does it contain a set experiment? It might. It contains a few. So I would check in there. There might already be something, but again, we haven't committed to anything yet. You know, generics, like Dan said, generics is really, well, generics is what opens this up, but generics is also really new, right? So what's the best way to do this? I don't think it's that obvious.
In Go 119, there is the pointer type. I think that might be the first time I've seen generics in the standard library. And this is in the
atomic package.
And so that's really cool. You can have an atomic pointer that's strongly typed. Are there other examples of generics used in the standard library coming?
I don't think yet. I think we're treading carefully because, like Cameron said, yes is forever.
Baby steps.
Yeah, no, I appreciate it. But there you go. There is one there. There is the first one coming in Go 119. Excellent. Okay. Another question is just next to you, so we'll do that and then we'll come down here.
Hello, Carlos. I hearing all of you, and I feel a little weird because using Go for more high level things, not like everything is a Go to December or the compiler. So we are using to make APIs. There are a lot of dependencies between different packages and services. So I came from Ruby on Rails. So this is so high. So Go is a little bit here. So I missed some stuff. And one of this is about testing. I know that Ruby on Rails is very powerful about giving you a lot of tooling to testing. So when I'm testing a full application that have a lot of dependencies in Go, I feel at the end of the day I am probably mocking 100% of all the packages. So I feel about, I don't know, because I don't have the answer, and I don't know probably if in the plans of tooling, only asking if you have some plans to evolve about testing, or you have some idea about more easy testing for Go. Thank you.
Okay, just so I understand your question, this is really about what kinds of important new features are going to be rolling out for Go testing, and in particular handling, sort of making it easier to mock your dependencies?
Is for example, using to mock, and in the end we are using author dependencies to mock, or we are making our own code to mocking. So you are developing, and at the same time you are thinking to develop also for testing. When I came from a world that normally you make your code and you totally apart, you make your testing code. So I feel sometimes everything is messed there. When I make, it's very powerful to make your own unit test. You have your small package, you have your own small test, but when dependency comes, I like more to make more integration tests to try the full happy path or that stuff. So sometimes I feel a little lost sometimes about testing in Go.
Okay, that's a super interesting question.
It is an interesting question.
Michael, do you think it's interesting?
Yes.
So sorry to ask this to Go runtime team.
No,
I told you that I came from more high level about the language.
It's a reasonable question. I mean, we don't have a lot we can say on this particular topic, other than I don't think anyone has been looking into this sort of specific thing. The testing package is very lightweight, is I guess one way I'd put it, and it's kind of that way on purpose. And so I don't know, certainly no promises either way, but I'm not sure that's a place where we're looking into investing, except for like fuzzing is a very, very fundamental operation and requires an engine and an algorithm, and so it makes sense to expose that. But sort of the higher level and really building test infrastructure, I think that's something that's mostly going to be left out of the standard library. But I don't want to say it's not no forever. It's no for now. But as far as I know, nobody's looking into this. But I could be wrong.
Yeah. I'm not aware of anything. That's what I was going to add. But it doesn't mean that it's not never going to happen. It's just some other priorities are probably a little higher. The work in fuzzing is the main sort of changes to the test package that I'm aware of.
One thing that we are going to try to roll out in the next Go release is a set of enhancements to coverage testing to make it easier to coverage test an entire application in an integration test type scenario, as opposed to just doing coverage test for an individual Go package. And in terms of wrestling with these kinds of testing issues, as somebody who works on the Go compiler and linker, it's a very similar situation. We really get the meaningful tests are the integration tests, and it's extremely difficult to write meaningful unit tests. For example, for the register allocator phase inside the compiler, it's almost impossible to really get good signal there. So.
Yeah, and I would say that sometimes you don't have to be fundamentalist about testing. Like having a pragmatic approach to what you test, what's important, it matters. And one example is like the file system, because it's tempting to mock the file system out so that you can do things in your code and check that your code's doing what you want it to. But there is a file system there, so maybe just use the file system in the tests. And the other thing, the testing package is very minimalist, but it's Go code. So you can really do anything. Anything you can write in Go can be part of your tests as well. So, and sometimes you do have to innovate there in the testing. But it's such an interesting subject, and it was a great question. Thank you.
Thank you.
I think we have time maybe for one more, maybe two. Look how he's ready to launch that. We are going to come down here. Maybe pass it down. That's quite a long way. Down this corner, please. Down there.
I don't see.
Anytime you're ready. Thank you. Yeah, keep going. All the way down here, please. Nice.
So, hi guys. I'm a beginner, I'm learning Go now, and I want to ask you your opinion about object-oriented programming in Go. So I want to hear from you. Do you think that Go can be an object-oriented program?
So object-oriented programming in Go.
Yeah, what do you think about it?
What I think about it in general?
Yeah. Sorry? No, in general, because when I talk with people, they say that Go can be a language, can be object-oriented program language. And some seniors say, no, that's not possible. And I'm really beginner, so I want to hear from you what you think about it.
I have an opinion. I mean, I have opinion on a lot of things, but I have opinion on this.
That's why you're here.
I think there's always room for these patterns, right, in lots of different languages. Like ultimately they're tools, and certainly the language pushes you in a particular way, right? Like Java pushes you in one way to a very strong inheritance-based object-oriented situation. I feel like Go is a little bit more loose on this, and if there's anything that I'd say that the Go type system really emphasizes to me personally is composition, which is something that's not typically represented in object-oriented programming. That doesn't mean you couldn't do something similar, like. But like, for instance, the feature that lets you embed a type into another one and like the methods are all lifted up, you could see that as a form of inheritance, but if you then add multiple of these embedded types, it's not multiple inheritance, it's composition. It's sort of its own thing. And so I think there's certainly space to think about it, to think about problems in an object-oriented sense in Go, but the language does push you in a bit of a different direction. To me, that direction is composition. I think interfaces are another really good example of that.
I guess the one thing I would add is that if you sit down to write a C++ program in an object-oriented way, it's really all about, okay, I'm going to design my my type hierarchy, and this is going to inherit from that, and so on and so forth. And with Go, my sense is that you're going down the wrong path by doing that, by starting with the types. It's better to more think in terms of the code and then sort of develop the types as you go along. At least that's my feeling.
And I would add, it depends on your definition of object-oriented programming. And remember that Go, one of the underlying principles is to try to not confuse the issue by making it, like giving you more ways of doing the same thing that might cause you distress later on. So one of those decisions is not to have inheritance. And so maybe that means that that type of object-oriented programming is not favored in Go. But that's because in another language you would have a choice between composition or inheritance, and then you'd go like all the way in one direction, say in Java, where everything is an object, and so that almost looks a little awkward in that way and creates a problem. So Go strives not to have to fall into that sort of a place where it's an awkward fit, and then there are multiple ways of accomplishing something where you might go and shoot yourself in the foot.
Yeah, to both of their points, I want to first emphasize what Dan said about like writing the code first, and then the types are just meant to represent what it is that you want to do. They're sort of kind of secondary, and I think to your point about like pushing towards composition, like. I think that's exactly what the push towards composition is trying to get you to do, that you write it one way, okay, now you need to generalize it, and now you leverage composition to sort of generalize it, whereas, again, in like an inheritance-based model, you sort of have to think about that up front. Yeah.
Yeah, and when I've done composition in the past, I've always regretted it because it's just more complicated than it needs to be. I feel clever at the time for doing it, and it's very satisfying. And then when I come back to maintain it, I'm like, I wish I'd just copied this thing here and just had it twice. Honestly, like, more of that. It's good. Well, this was great. Thank you so much. They were amazing questions. Give it up for the panel, please. Thank you very much, Than, Cameron, Michael.